Chemical properties. In this video, we are going to see chemical properties. These properties refer to how materials behave when they make contact with other chemical products. Oxidation. Oxidation is a chemical process in which an atom loses electrons. We say that the atom that loses electrons oxidizes, and the one that gains them is reduced. Oxygen in the atmosphere is an oxidizing compound capable of robbing electrons from many metals. When oxygen robs electrons from a metal, it is combined with, meaning oxygen stays attached to the metal, forming a new compound. For example, oxygen robs electrons from iron, and this causes a chemical bond between the iron and oxygen, resulting in ferrous oxide, Fe2O3. Ferrous oxide creates a reddish-colored layer of rust. This rust is dissolved with rainwater and even with the humidity from the environment, and is then released from the material, causing irreparable damage, which we call corrosion. In some metals, for example aluminum, the surface layer of oxide acts as a protective layer, preventing the inside of the material from being oxidized. Or rather, in some cases, oxidation can be beneficial. Corrosion. The most widespread cases of corrosion are caused by the joint action of oxidation and water or humidity in the environment. Oxidized metals like ferrous oxide that we saw in the previous case are usually soluble in water, so they dissolve in it, and are detached from the material, decreasing its thickness while reducing its mechanical strength. Like we said, oxidation can be a good thing in some cases, given that surface oxidation in some materials impedes oxygen from penetrating the inside of the material. However, corrosion is always negative. Corrosion implies the loss of the material. Galvanic oxidation. Let's talk now about a special type of oxidation, galvanic oxidation. This type of oxidation is very important in technology since it occurs when we combine two different metals with a different electrochemical potential. In this table, we can see the oxide reduction potential of the main metals. Remember that oxidation is produced when an element robs electrons from another. Well, positively charged metals can steal electrons from negatively charged metals. That is, electropositives oxidize electronegatives. An example of this is the case of the Statue of Liberty. This monument has an iron frame covered by a copper skin. The outside part, the statue itself, is made of copper, and the internal structure, which keeps it standing, is made of iron. As we saw in the previous table, copper has a potential of 0.34 and iron of -0.44. If the iron is touched, it would undergo galvanic oxidation. Engineers put a layer of electrical insulation material at all of the iron-copper junction points to avoid direct contact, but this requires an extremely expensive maintenance of the monument. The American Scientific Society, a month after finishing the assembly of the statue, admitted 5 dangers: terrorism, earthquake, wind, lightning, and galvanic oxidation. Here, we can also see the oxidative effect of oxygen on copper. The monument was originally a brilliant copper, but as the decades passed, this color evolved into the blue-green tone we know today. This color change is owed to the external oxidation of the copper by effect of atmospheric oxygen. Chemical inertia. Chemical inertia is the quality of some materials to not react chemically with other compounds. This quality is very important in the food industry as well as in medical prosthetics. If foods react chemically with the packaging material that contains them, their taste is altered and they can even be harmful to health. For this reason, many tin cans are internally coated with a thin layer of polymer to avoid the transfer of flavor to food. Aluminum cans are considered the highest quality, not only for the reduction of weight, but also because aluminum does not transmit flavors to food. Chemical inertia is also necessary for medical prosthetics. We do not want to insert anything into our body that can react chemically with it. The screws shown in the photo are made of titanium.